Hello everyone. Today we're gonna learn about MOSFET. So the MOSFET stands for metal oxide semiconductor field effect transistor. So the MOSFET are used in higher amp applications. They are three-terminal device. The three terminals are gate, drain, and source. Unlike BJTs, MOSFETs are voltage control device, which means that there is no base current and the voltage at the gate terminal will determine how much current will flow through the drain to source. But before moving to this circuit, we need to learn a little bit about BJTs. So the BJT stands for Bipolar Junction Transistor. It is also a three-terminal device. It is used in lower amp applications, usually less than 1 amp. So in BJT, the base current will determine how much current will flow through collector to emitter. So you can say that base current is directly proportional to collector current, and it can be also written that beta times IB equals to IC, where beta stands for the gain of the transistor. So now in the circuit I have used a 10K potentiometer. Now the potentiometer will increase or decrease the resistance, which will in turn increase or decrease the base current, and which will then increase or decrease collector current. Small changes in the base current will lead to higher changes in the collector current. Now let's look at this circuit. So now here is the circuit. Now on increasing IB, IC also increases, and on decreasing IB, IC also decreases. This can be seen by dimming of the LEDs. So we are back to MOSFET. Now earlier we have seen that transistors were pretty good at switching small circuits, but one of the main disadvantages of the transistor are they cannot be used for higher amp application like the MOSFET. For example, let's look at this circuit. Here I have used an IRF Z44, which is an N-channel enhancement type MOSFET. Looking at the data sheet of this MOSFET, I came to know that VGS, the minimum gate to source voltage, is 2 volt, which means that which means that 2 volt is required at the gate terminal of this MOSFET for the current to flow from drain to source. Anything less than 2 volt, which means that the current will not flow from gate to source, and the MOSFET will be off. So now let's look at this circuit. Here I have used an 12 volt power supply, and instead of providing separate power supply for the gate terminal, I have used the 12 volt for both the load and the gate. Now here the position of the wiper of the potentiometer will determine on and off state of the MOSFET. So when the position of the wiper is at 1, VGS is almost 12 volt, which means that the MOSFET is fully on. When the position of the wiper is 2, so VGS is almost near to 0, which means that the MOSFET is turned off. So the positions between 1 and 2 will determine how much current will flow from drain to source and hence through this motor, which will control the speed of the motor from 1 to 2. Now let's look at the circuit. This is our load, the DC motor. This is our MOSFET IRFZ44. I have also included an heat sink because this thing gets hot. And here is the potentiometer, which will adjust the gate voltage, and the gate voltage will then adjust the speed of the motor. Now let's check this out. As you can see, now let's decrease the gate voltage. So you can see, on increasing the gate voltage the speed also increases, and decreasing the gate voltage the speed also decreases.